Now let's look at Liskov's substitution principle, which is the third principle of solid principle. Objects of a superclass should be replaceable with objects of its subclasses without breaking the functionality of the program. So what this means is that I have a class which is a parent class. Let's say the class is bird, and I create a new class called penguin. And let's say this penguin is child class of bird parent class. Now what Liskov's substitution principle says is that the child class should match the expectation of its parent class. So if bird represents flying bird, then its child class should also be a flying bird. But in this case, if penguins cannot fly, so it does not match the expectation of its parent class. And this violates Liskov's substitution principle. Let's see what I mean by this in code. So let us create a new file called Liskov Substitution Principle.ts, and quickly, as usual, let us modify the package.json, Liskov Substitution Principle. And now let me paste a bad code example first. So this is a bad code example. Why this is a bad code example? Because we have a class which is a parent class bird, and this has a method called fly. And if I create a subclass of bird, which is penguin extends bird, then if I have to implement this method fly, but this should throw an error because penguins cannot fly. So this does not follow Liskov substitution principle. Instead of this, what we can do is, so now let us transform this bad code into a good code. So the aim is that we want to create a subclass that does not violate the expectation of the parent class. So let us create a class called bird, and let us not add any methods or fields to this bird class. And let us create a new class that implements or extends this bird class. So let us create a child class called flying bird, and this extends bird. And let us create a method called fly, and obviously this is a flying bird, so let us console log out flying. So we have created a child class of bird class, which is a flying bird. Now, if I want to implement if I want to create a child class for whichever the bird is a flying bird, then I can directly create a child class and make flying bird as the parent class. And if I want to create penguin, then instead of making flying bird as its parent class, I can make bird as its parent class. Let's see what I meant to say. So if I have a class called penguin, and I can, instead of making it a flying bird, I can make this as bird. So bird can be flying bird or non-flying bird. So I can create a method called swim, and I can console.log swimming. So now this does not violate Liskov substitution principle. Every subclass or parent class has its own expectations, and the child class matches the expectation of the parent class. And in this way, we have transformed bad code into a good code that follows Liskov's substitution principle.